Okay, I'm going to talk about the LTM package that stands for latent trait models. You can easily install it through the install package LTM through quotations. You can install it successfully on your laptop computer. Then you execute the library command for the LTM. LTM is if you get help through F1 key on your keyboard. You can find help about the latent trait models for item response theory models. Uh, it is actually do a variety of analyses, including the descriptive. The descriptive is actually the classical test theory and summary for classical test theory statistics. It is also doing analysis of item response theory for dichotomous data, including the RASH model, two-parameter logistic model, the three-parameter, actually the Birnbaum model for the three-parameter logistic model, and the latent trait model is also doing analysis through even dimensions that maybe have an interaction with each other to actually predict the item response answers. So it is also showing you goodness of the statistics through bootstrap your chi-square for RASH and other Optimus item response models, including generalized partial credit models, grade response models, and even you
F1 doesn't.
you should press F1 on your keyboard. You first if you want to get help from any packet, just type the name of the package, and then hold the cursor on the packet, and then holding the cursor on the name of the package simultaneously, you should press F1, and you can see the help provided on the right side of your window. Okay, so okay, so you can get classical test area measures simply by uh, getting the descriptive statistics for your data set, and the basic item response theory models, and even you may want to have plots for example item characteristics, curves, item information curves, and test information functions and curves. That is important to analyze your test, to know how informative your items or your tests are. So uh, let me just um, do an analysis for there is a data set named abortion that is about attitudes towards abortion. The data contains responses given by 410 individuals to 4 out of 7 items concerning attitude to abortion. And you can see the data set if you press F1 in the data set. You can have a full window for help about this dataset, and you can also show it on your desktop. You can see that there are 4 binary items, including 0 and 1. 0 is agree and 0 is disagree, and 1 is agree. And this is because this is attitude questionnaire, so it is about agreement and disagreement, not true or false. And the way that you can treat this item response data is it is similar to the true-false items of the test. So you can do a classical test area analysis or item response theory analysis like that. It's not different. The items, item 1 is about whether the woman decides on her own that she does not have it. It means does not have an abortion. Okay. It's telling just the woman decide on her own to have an abortion or not. Okay. The second item is about the couple agree that they do not wish to have a child.
So it's like a mixed.
It's not like it. It's agree or disagree. It's true or false. It's binary item. Agree or disagree. Just I agree or disagree. Okay. The second item is about the couple agree that they do not wish to have a child. The third item, the woman is not married and does not wish to marry the man, so she decides to have an abortion. And the fourth item, the couple cannot afford any more children. That's why they have an abortion. The woman has an abortion. Okay. This is real survey data that done in 1986 in UK. Okay. So if you want to have a descriptive analysis about this data, the descriptive analysis actually do the classical test theory analysis that we also did it on the site package, but it is more clear, summarized, and it's not so messy. It's very summarized and right to the point. Okay.
You just copy that and paste it in.
You just use the descript function. It's the function of LTM, and it is the data set. The data set is abortion because it is a data set that is included in the LTM package. It's not required that you introduce or you call the data or import the data because it is in the package. So the syntax know the data set, so it is doing on the abortion data set on the package. Okay, so I'm going to command the descript function to do the classical test theory on the abortion data set, and I name it DCS. Okay, I ran it. Okay, when I named a function to something, I actually if I want to call the output, I have to type the name of the analysis that I did before. So I type DSC. So when I execute this command, I have the classical test theory analysis very easily uh, the proportion for each level of response. 1 is agree and 0 is disagree. So for the first item, the majority disagree with that, and they don't believe that this is the only choice for the woman to decide whether or not have an abortion. Okay, but the 3 other items, you can see that the majority agree with that, with the 3 other items, that the couple uh, agree about the abortion, or the woman do not the woman does not want to marry the man, and the couple cannot afford abortion. Uh, the logit is it is yes, the logit is about the doing the analysis through the proportions of agree and disagree is going to call to the logit. Okay, the logit is about if the agreement is more than disagree, the logit is positive, and
so if it's negative,
yes, it's actually about the proportions. But as I said, this proportion, the endorsement proportion or agree proportion, is called the difficulty measure. Yes, we call it the difficulty measure in classical test theory. We have also frequencies of total scores, because we have a scale of 5 items. So we have a total score of 4, 0 to 4. Okay, so you can see the frequency of the total scores for the scale. Okay, and we have also point biserial correlation with the total score. What's that? I said it before. It is the point biserial correlation with the total score. It is the discrimination index. Discrimination index for each item. We have the included item and excluded item. The excluded item is actually the corrected version of point biserial correlation, and it is more precise than the included version. So you can see either the included or the excluded version of point biserial correlation are high, positive and high. So we have a very good scale with discriminative items. So
higher than 0.6 is good.
it's close to 0. It's close to 1, because
So
it's more
what is
than
the minimum scale? What is the minimum? 5 or 6?
when it is more than 0.5, it's high actually.
More optimal.
Yes, it's high. When you have a correlation more than 50%, it's high. You have also Cronbach alpha. The all items Cronbach alpha is 0.87. So because of the discriminative items that you have in your scale, you have also a good and consistent measure that have a very good internal consistency.
So what about this one? 0.6. Higher than that?
There are some cut points for Cronbach alpha. The more liberal cut points is about 0.6, and the more conservative are more than 0.7. You know, it's actually in research, if you are going to do the research. But some books believe that if you want to use a test or a scale for the clinical purposes, you should have more reliable measures or tests. But for the sake of research, the point even about the 0.6 is enough for you to do the analysis with the measure. And through the LTM function, we have the same function, the same name for the package in this package, the LTM function. It is the latent trait model, latent variable model for binary data. In language assessment, more often you have the binary item, the true or false. You actually correct the items in a binary manner, like items. Okay, so and the well-known models for item response theory is actually the binary models. We have the RASH model, or one parameter logistic model, the two parameter logistic model, and the three parameter logistic model, as you can see here. Through the details of the item response theory, as I said before. In one parameter model, we have just the difficulty parameter. In two parameter model, you have also the discrimination parameter, and the three parameter model. The guessing parameter is also included in the model, so you can estimate all of these parameters in your model. Okay. There is a data set in your LTM package that named VIRS. It's a workplace industrial relations survey data. It is also these data were taken from section of the 1990 Workplace Industrial Relations Survey that stands for VIRS, dealing with management worker consultation in France. The questions asked are given below. You can, if you press F1, you can have the question. There are 6 questions that please consider the most. It's the instruction for doing the survey. Please consider the most recent change involving the introduction of the new plant machinery and equipment, where discussions or consultations of any of the type on this card have either about the introduction of the change or about the way it was to be implemented. So it's the instruction, and the actually workers are going to answer this question. Informal discussion with individual workers, meeting with group of workers, actually about the manager and superintendents. This is the questionnaire that is actually for the superintendents and the managers of the workers. Informal discussion with individual workers, meeting with groups of workers. It's a yes or no question, so it is binary. It's not Likert scale. It's also binary. Yes or no questions sometimes is better than Likert scale, because if you do the Likert scale, they are going to endorse the average, the median of the scale. So if you force the respondents to answer in a true or false mode, or agree or disagree, They
Come up with a
just
better
give
result.
you, yes, they just give you some more real answer than the Likert scale. It's actually Likert scales give you an option to be more conservative. Okay? Yes. Item 2, meeting with groups of workers. Item 3, discussions in established joint consultative committee. And item 4, discussion especially consult committee to consider change. Item 5, discussion with the union representatives at the establishment. Item 6, discussion with paid union officials from offices. Okay, you can see the reference of this article. You have also, you may want to have also a descriptive analysis like that. You can see that the Cronbach's alpha is actually low because of the first item. First item is not a good item. Yeah, because the discrimination parameter is very low. Okay, and if you and actually if you exclude the first item, the Cronbach alpha is increasing to about 0.53. Okay.
So if you remove those items, the value will increase.
Yes, yes. Or you may want to modify the item contents. Okay. Let's do the analysis for this data set through this command, telling that we just want to have a unidimensional scale that is actually these items only measure in one dimension, and we have also setting some constraints through some matrices. These constraints actually tell you when you use this. See, this is a vector that tells you about the constraint that you want to set on your items. For example, we want to set, actually we want to set the easiness parameter. The easiness parameter is, it's the first one is about the item. So for the first item, we want to set two constraints. So we write two vectors here. We set for the first item, and the easiness parameter should be fixed on 1. Okay? And for the second parameter, the discrimination parameter, it's a 2-parameter model. When you run the LTM function, it is automatically do the 2-parameter logistic model. Okay, so you have the difficulty parameter and you have the discrimination parameter. So in this example, we just want to set two constraints. For the first item, the easiness parameter should be fixed on 1, and for the sixth item, the discrimination parameter should be fixed on negative 0.5. Okay? If you do the analysis through the LTM model, for the sixth item, you have two parameters estimated, the difficulty parameters and the discrimination parameters. Okay? So you can see that, as I said, the range for the difficulty parameter for a well-fitted model is about -4 to +4. So if you find either for the difficulty or for the discrimination parameter, if you find, for example, a discrimination parameter like this, you should be actually it's a item that should be candidated to be eliminated. As I did the classical test analysis, you found that the first item is not so discriminative. So you find that the discrimination measure is out of range, and if you get some fit measures for this item, you can find the first item is not fitted to the model.
It could be between group -4
The well-fitted item,
higher than that is not good.
the higher or out of range values indicates the misfit of the item to the model. Okay, so as you can see, the first item, like the classical analysis, in the classical analysis, you also found that the first item is not well discriminated. It's about 0. Okay, and in the two parameter item response model, it is also found that you have an out of range discrimination parameter. So both of the analysis shows that the first item is not good.
But the difficulty is good,
Both actually, both parameters should be well fitted to the. Yes, if one of them is out of range, it is an indication for the misfit of the item. It is also possible that you do the actually actually get the goodness of fit for each item through the this package or other packages like MIRT, and I'm going to explain it further in the next sessions.
The second one is good, the third one is good, but the fourth one is not good, right?
The other, yes, this is the only. The fourth item is also.
It could be accepted.
It is acceptable. It's around 4. It's not so out of range.
So we shouldn't be so strict.
It's about the -4 to +4. It's also an acceptable range. So there is other measures like log likelihood measures that it is actually a relative goodness of fit measure that you can compare the models with each other. The lower the log likelihood measure, the better fitted the model. Okay.
So how much lower?
The lower to 0. It's not going to be close to 0, but the lower, actually positive or negative, the lower the better. Okay. So it's actually a relative goodness of fit measure compared to the global or absolute goodness of fit measures provided by chi-squares and p-values. These are absolute goodness of fit measures that actually compel you to accept the item or not, or the whole model or not. Okay, but the relative goodness of fit measures like the log likelihood than the other measures like BIC or AIC actually calculated through the log likelihood measures. These are all the relative goodness of fit measures that should be considered. We have also a model, a very simple model without any constraint for the abortion scale. The two-parameter abortion. The abortion scale was very nice. We had not any actually non-discriminative items, and the whole scale was very good and very consistent. So we expect that the model, the item responses model, is also actually work good for this model. So we ran this. It is actually we have also some controls for some technical steps for doing the marginal maximum likelihood algorithms. For example, we want to do the analysis through 20 quadrature points and with 20 EM or expectation maximization iteration. These are some technical steps for doing the analysis. You may want to delete these constraints, this control list, and it's also doing the work for you just good. And we just did analysis for the abortion scale.
If the second one goes in states, it's around 4.
It's wrong, it's acceptable. It's around 4. You can see that the difficulty measure, like the classical test analysis, you have difficulty measures for the first item different from the other items. Okay.
So the likelihood is good or not, because it's not near 0.
Likelihood is, if you want to actually reference to the likelihood measure, you should do some models, you should run some models for the same data. Okay, let's for example, I just want to run the rash model for the abortion data set. Okay, same data set, different models. Then you can compare the log likelihoods. Not in this case, you cannot compare the log likelihood for the abortion data with the log likelihood for the actually VIR data. These are different data sets. You should compare the log likelihoods for the same data sets, not different data sets. Different models for the same data sets. Okay, the log likelihood can be compared for different models on the same data set, not different models for different data sets. It's not acceptable. There should be a same data set with different models. Then you can compare different models, item response models, with.
So if all of them are near 0, it's good. But the majority of the models,
forget the 0. It's not going to be close to 0. You just compare the log likelihood with each other. You can say that this model is better than that model, or you can use a function like ANOVA for statistically compare different models. Let me do this analysis. This is a 2-parameter model. As I said, the LTM package do the 2-parameter logistic model for the data automatically. It's default on the 2-parameter model. You can also set the constraints and do the other models, but there are functions that make it easier for you. For example, if you want to do the rash model for for this data set, you can actually uh, use the rash model here. We have this here, rash model, okay, and I just it's enough for you to go for the data and do the same. You just insert the name of the dataset and run the analysis. And in Rash model, you just you have a fixed discrimination index for all of the items and different difficulty measures. And it is very interesting that you have a lower log likelihood. So the Rash model is actually better fitted compared to the two-parameter logistic model. Even if there is not a significant difference between two IRT models, the simpler model is better. You should accept, you should do the analysis through the simpler model.
So your simpler model is?
Yes, the Rash, because why it is more simple? No, because it actually has less parameters than the two parameters. It also have the difficulty parameter. So the simpler model is better to be selected or chosen for doing the item response analysis. If you want to do the item response model, the simpler model is the better.
So prefer these likelihoods together, these two together.
Yes, let's do the three-parameter model. We have also the TPM model or three-parameter model that Birnbaum invented this model, actually proved it. So if you do the three-parameter model, let me just we have the TPM here. This is the three-parameter model. This function actually fit the Birnbaum three-parameter model under the item response theory approach. So if you run this function for the abortion dataset, the guessing parameters is also the guessing parameter is also calculated. So because it is a questionnaire, the guessing is not so meaningful. So I recommend that you do the three-parameter model for a test, not for a question. Okay, because guessing is not logical for questionnaires. You just endorse an option in questionnaire, not to guess. Okay, guessing is for testing, language testing. You do this. There's no guessing. It is also showed that the guessing is about zero because it's a questionnaire. It's actually an attitude question. So it's that simple, isn't it?
Yes.
That simple. You can also, you may want to do, let me just.
Doesn't matter. I mean, yes, you do everything. Somebody is this way also.
It's JMetric. JMetric. It is also the JMetric software is actually, I think it's JMetric that do the analysis. Item response theory models actually run through different software, but R provides you with the newest version of the package that you can run the item response theory model. Okay.
M plus.
Yes, M plus. M plus is a commercial software. It's not free. You should buy it. It's a commercial software.
So it gives you more complex analysis than the species analysis, or the same?
Not necessarily. You can do the same analysis through R or Python. Python and R actually do all of the analysis for free. And these softwares are supported for free. The newest version are available for scholars for free.
But M plus is not free.
No, M plus is a commercial software. You should buy licenses and I recommend R. All of the scholars recommend R for analysis. There is also there's also some functions that provide you with the plots. Okay. If let's endorse the Rasch model for our scale. The Rasch model is the best model that is fitted to your data compared to other item response theory models. Let's call it R. Okay, I name it R. So then you can draw plots for this model, for the Rasch model. You can do the same for the other item response theory models. Okay. If you go to the LTM package and search for the plots, you can find the plot Rasch. You have also the plot ATM, you have also the plot TPM. Oh, if you run item response theory model for Likert scale, like you should actually fit the GRM model or GPCM model. But in this case, we deal with binary items and we fitted the Rasch model, so we call the plot.Rasch. Okay, the model is named R. If I run this, it's too large. Okay, figure margin too large, or let me just do it for each item. Okay, X, it's an object inheriting either from class GPCM, class GRM, or Rasch. In this case, Rasch. X is the name of the model. I call it R. The type, actually I want the ICC. item characteristic curve. I is it okay, and I ask for the number of items. It's um, it's a numeric vector denoting which item to be plotted. All items are plotted. If 0, it should be a vector. So I type the C through the parentheses. I just run the first step. Okay. Let's do the plotting for the VIRS dataset, because the margin should be actually mentioned in the syntax. Let's fit the RASH model for the VIRS data. We run this analysis. So for these 3 items, the item 1, item 3, and item 5, we just ask for plotting the fit object here, the model that we ran for the RASH model. We also determine that the scales of the plot through LVD and CX with these sizes 3 and 1.4. Because in this package it's not done on default. So if you do the plotting for this 3 item, we have the margin too large. Awkward because it doesn't run even their own examples. Let's do an analysis for the LSAT, the law school. Datasets, plotting with some more precise measures. You can here